Hi everyone, in this lesson we're going to be solving exponential and logarithmic equations. So we have a warm-up to start. It says write without logarithms. So we're going to condense the right side first. And that's going to give us, since we have addition between, when we condense the logs, we're going to have multiplication. And also we just want to note that that 2 can be brought up because of the power rule. So we're going to have BC squared. And then because we have log base 10 on both sides, just like we could add log base 10 to both sides, we can also take away log base 10 from both sides. So we can remove the logs, and this would be A equals BC squared. Right, on the other side, I'm going to rewrite the right side before I continue. I'm going to bring that 3 up. Okay, and again, if we have log base 2 on both sides, just like we could add it, we can also take it away. All right, so how to solve exponential equations. We're going to take the log of both sides, and then we're going to solve for the variable, right? Because the whole point, mostly the whole point of logarithms is if we have a variable as an exponent, using a log, we're able to bring that variable down and solve for the variable. So if we look at example 1, it says solve 4 to the x equals 15. So we want to take the log of both sides this way. We can bring that x down in front. Now, I'm going to use the log base 4 of both sides. And the reason that I'm going to use log base 4 of both sides is that log base 4 of 4 is just 1, right? Log base 10 of 10 is 1. Log base E of E is 1. Log base 450 of 450 is 1. So that makes this part very, very easy. That just is 1. And the x is going to come in front. So now x is equal to log base 4 of 15. And I can put that into my calculator. Now, this is the exact answer. All right, if I put it in the calculator, I'm going to get a rounded answer. Let's look at that. All right, so we're going to go to math, and we're going to scroll down to the log function. And in this case, we want log base 4 of 15. And that's rounds to about 1.95. Now, you could also, if you don't have that function in your calculator, you could use change of base, and we would do log of 15 divided by log of 4. And we get the same answer. All right, moving on to example 2. All right, I'm going to take log base 2 of both sides, because log base 2 of 2 is 1. Now, something you might notice, you may or may not notice this, but 32 is the same as 2 to the 5th. So I'm going to rewrite the right side. Just another approach we could take here. We have log base 2 of 2 to the 5th. And then what happens is, since we have log base 2 of 2 now, here and here, that's just 1, and we can bring down the exponents in front. And that's going to give us so final answer here is x equals 5. We have 2 different types when we're solving a logarithmic equation. We either start out where we have log to the same base on both sides, so therefore we can just take that away, and end up with what's here. Right? So if you have a single log on each side of the equation having the same base, then you can just set this equal to this and proceed from there. So we're going to get x plus 3 equals 8x plus 17 and solve for x. So x equals -2. Now type 2, right, is where it's in logarithmic form, and we really need to convert it to exponential form to help us solve the problem. So if you have a single log on one side of the equation now, you can express it as an exponential equation and then solve it. And we want to put it in exponential form. It's base raised to the exponent equals the answer. Base, answer, exponent. Base raised to the exponent equals the answer. All right, so in this case, we're going to have 4 raised to the second power equals x plus 3. Right, 4 squared equals x plus 3. Okay, now another important thing to note, you always want to remember to check for extraneous solutions. Okay, it's okay to have values of x that are positive, negative, and 0. However, it's not allowed to have a logarithm of a negative number or 0 when substituted or evaluated into the original log equation. So even though the algebra may give us a solution, we always have to take that solution, put it back into the original equation, and see if it still works. Now, there's lots of different ways to approach a log problem, and the only way you're going to get good at it is practice. So there's a lot of practice in this lesson. And if you notice on the left side, we have log base 6 of x plus 5 plus log base 6 of x. The first thing that we really need to do here is condense what's on the left side. So we have plus between, which means when we condense, we're going to have multiplication. All right, that looks better already. So we're going to now put it into exponential form. This is the base, this is the exponent, this is the answer. 6 squared equals x times x plus 5. We have 36 equals x squared plus 5x. Move the 36 over. Factor. Solve for x. All right, we got 2 solutions, but now we want to check for an extraneous solution. Now, if I put -9 in here, for example, -9 plus 5, that gives me -4. That is outside of the domain of a log, so I know that -9 will not work. It also doesn't work if I put it in right here. If I put -9 in there, that value, whatever's here, has to be greater than 0. Right? So -9 doesn't work. Now if I put 4 in here, I get 9, that's good. If I put 4 in here, that's just 4, that's good. So the value of 4 is a solution to example 5. All right, we have a lot of practice here. All right, now what I'm seeing here when I look at number 1, and then again, this just comes from experience of doing a lot of these kinds of problems. I know that 64 is 2 to the 6th power. I know that 64 can be rewritten with a base of 2. So let's see here, 2. And I really like that because now I could take the log base 2 of both sides, and log base 2 of 2 is just 1. Right, so for both of these, I'm just going to bring that 6 in the front and the 4x minus 2 in the front, and the log base 2 of 2 goes away because it's just going to be 1s. All right, the next one I can see right out of the gate here that 125 can be rewritten as 5 cubed. And 25 can be rewritten as 5 squared. That helps me a lot. Now I know I can take the log base 5 of 5 of both sides, right? Log base 5 of 5 is 1. I can bring the 3x in front. I can bring the 2 in front. So 9 can be rewritten as 3 squared, and 27 can be rewritten as 3 cubed. I think these are kind of fun. I bet you do too. Now I can take log base 3 of both sides. I'm just going to rewrite this, distribute that too. It looks a little nicer. All right, now log base 3 of 3 is 1. I can bring the exponents to the front because that's what we love about logs. All right, moving on to number 4. Now, I'm looking at 12,143, and I have no idea what base I could write that as. So this is an exponential form. I don't know what to do with it, so I'm going to put it in logarithmic form, right? So our base is 8. Our answer is 12,143, and our exponent is x, okay? And then I could just put log base 8 of 12,143 in my calculator, and I would get a solution of x is approximately 4.52. Now there is another way we could have approached this guy, so I'm going to do that in blue. Maybe you didn't want to put it in log form, you just want to take the log of both sides. I'm going to take the log base 8 of both sides. And now you notice on the left side, log base 8 of 8 is just 1. So I end up with x equals log base 8 of 12,143. It's just two different ways of thinking of it. All right, now with number 5, the first thing we want to do is we want to isolate that e to the 5x, because that 9 there is really kind of troubling. I'm going to divide both sides by 9. Just to make this look a little nicer. Now, you can put it in logarithmic form, or you could take log base e of both sides, which I think that's what I'm going to do. I think just looking at this, that seems the easiest. Now, remember, log base e of e is just 1. Log base e can be written as ln. It's shorthand. Ln is log base e. So I'm going to take the ln, the log base e of both sides. A little less writing, I like that. And log base e of e, ln of e is 1, so we end up with 5x equals ln of 141. And so x is equal to ln of 141 divided by 5. In my calculator, that's going to give me approximately 0.99. Right? Just like number 5, number 6, you want to isolate that exponent, that e to the 12 minus 5x. So I'm going to add 7 to both sides to start. Try to make it look as simple as possible before you get involved with logs. I'm going to take the ln of both sides because the ln of e is 1. Right? The ln of e is 1, so I'm able to bring this in front. And then that's just times 1, so I don't have to write anything other than 12 minus 5x now on the left side. And then solve for x. When we put that in our calculator, we're going to get approximately 1.43. And really be careful when you put this in the calculator. Notice I put this parenthesis here. We need that there when we put that in the calculator, or you're going to get the wrong answer. All right, moving on to number 7. This time I'm going to use the method of putting it in logarithmic form. Right, this is my base, this is my answer, this is my exponent. Okay, so we have log base 5 . And now we just solve for x. So you have to put all of that in your calculator. You have to put log base 5 of 37,500. Make sure you put parentheses here, minus 2 divided by 4. You're going to get x is approximately 1.14. Okay, the next one, I think for fun, I'll take log base 3 of both sides. That x plus 4 can come down in front. Log base 3 of 3 is just 1. Right, so final answer, log base 3 of 64 minus 4. So x is approximately negative 0.21. And last one, I'm going to put this in logarithmic form. So we have log, my base is 16, my answer is 1 over 64, and my exponent is 4x minus 2. Okay, solve for x. So if you put this in the calculator, you'll get x is approximately 0.125. Right, at this point, you should start to be feeling better about these. We have more practice now where they look a little different. We're going to start in log form, and then we're going to proceed from there. So it says solve each log, and now I'm asking you to check for extraneous solutions. So this is in log form. I'm going to put it in exponential form. Base is 4. Our exponent is 3, equal to our answer, which is 3x minus 5. Okay, 4 cubed is 64. Plus 5 divided by 3 will give me x. So x is equal to 23. If we put 23 in here, we're going to get a positive number. So that works out. This is not extraneous, so our solution is x equals 23. Isolate the log before you start in number 11. That means we're going to subtract 3 and divide by 4 before we begin here. So we've got 4 ln 2x, and this is 12, and then divide both sides by 4. We want to simplify this as much as possible before we start. Now it's in log form. We're going to convert it to an exponent. If that ln really bothers you, just rewrite it as log base e. The base is e, the exponent is 3, the answer is 2x. So e cubed divided by 2 is equal to x. All right, if we put e cubed divided by 2 into our original, we're going to get a positive number. That's fine. All right, so that's our solution. If we put that into our calculator, let's practice that. We're going to use the ln button, but it's second ln. So we have e to the third power, or you could just use the e button, that second division symbol, raised to the third power. And then that's going to be divided by 2. So that's about 10.04 rounded. That just looks a little nicer to me than e cubed over 2. Now for number 12, we have to get the logs condensed on the left side. We have addition between, so that means when we condense the log, it's going to be multiplication. Now we're going to put it in exponential form. Our base is 2, our exponent is 4, and our answer is x plus 3, x minus 3. Solve for x. So we're going to get x equals 5 and negative 5 when we solve that. If we put 5 in here, we'll get a number greater than 0. But if we put negative 5 in here, we're going to get a negative value, and that's not allowed with logs. Domain of a log is greater than 0, so we know that the only solution that works here is going to be positive 5. Condense the log on the left side. We have subtraction between, so that's going to be division. You really need to know your properties now. It's really being put to the test. The base is 3, the exponent is 2, the answer. Okay. We have a fraction. You can think of this as 3 squared over 1. We're going to cross multiply, so we're going to get 3 squared is 9 times x plus 2 equals x minus 1. And solve for x. So here we're going to get x is equal to negative 19 over 8. If I put negative 19 over 8 here, I can see I'm going to get a negative number. So even though I only got one solution, it can happen where that one solution, even that doesn't work. So this one is no solution. There is no solution. Right, condense the logs on the left side. We have division because it's subtraction between them. We have ln at both sides, so we can just remove ln from both sides. Cross multiply. If we put 2 into either of these, we get a positive number. If we put negative 2 in, it's going to cause a problem right here. That's going to give us a negative 1. So the negative 2 doesn't work, but the positive 2 is fine. All right. Condense the log on the right side. We have log base 4 on both sides, so we can take away log base 4 from both sides and then solve for x. When we check for extraneous solutions, if we put a 4 into any, we get positive, we get a positive, we get a positive. If we put negative 4 into any of these, let's check that. Here, a negative 4 is going to give us a negative number, so it doesn't work. So we know that only positive 4 is a solution. Okay. First thing we want to do, always, always, always isolate the log. We want to divide both sides by 2. Now we can put it in exponential form. Again, if that ln bothers you, rewrite it as log base e, and then put it in exponential form. The base is e. The exponent is 4. The answer is 3x. So e to the 4th divided by 3 equals x. That's a big positive number. A big positive number times 3 is still going to give us a positive number. So we know that's a solution. It's really not very pretty to look at. So I'm going to put that in my calculator, and I'm going to get x is approximately 18.20. All right, last two here. Condense the left side. All right, put it in exponential form. The base is 10. Since nothing's written, we assume it's 10. The base is 10, the exponent is 2, the answer is x squared plus 15x, x times x plus 15. So we get 0 equals x squared plus 15x minus 100, factor that. So x is either negative 20 or it could be positive 5. If I put a negative 20 in there, definitely not going to work. If I put 5 in there, it works. So our only solution here is 5. And number 18, condense the left side. We have ln on both sides, so we can remove ln from both sides. Cross multiply. Make sure you distribute the 6 to the x and to the 1. Solve for x. We put -2 right here. We can see we're going to get a -6. That doesn't work. This guy is no solution. All right, if you made it all the way to the end of this video, well done. There was a lot in it. You're going to have lots more practice. Thanks for watching. Have a great day.